Hello and welcome to the LEEP Summit. I'm Mike Witherell, Director of Lawrence Berkeley National Laboratory. I'm proud that Berkeley Lab is home to Cyclotron Road, the first of the LEEP nodes. In 2014, when Cyclotron Road was born, our goals were simple. By offering talented inventors access to the superb expertise and facilities available at a national lab, we hope to help some of the most promising ideas in energy tech survive through the riskiest stages of R&D. By providing the fellows an income, we also hope to provide access to entrepreneurs who might not already be financially secure enough to put their careers and lives on hold while exploring an unproven technology. In 2015, Cyclotron Road announced its first cohort of 9 inventors, representing a diverse community, each with an idea they felt very committed to. Through our nonprofit partner, Activate, we have since built in professional development and a community of support. To have the greatest possible societal impact, we're investing in our fellows as much as we're investing in their ideas. By 2016, we had a working model, DOE was ready to replicate the program, and here we are, 4 LEEP nodes at our 4 national labs. And because it's a great idea, there will be more in the future. I'm proud to be able to say that since 2015, Cyclotron Road has supported 75 fellows from 56 companies. Those fellows have so far raised more than $400 million in follow-on funding and hired more than 400 employees. Most important, expanding diversity, inclusion, and access continues to be our guide star in encouraging, selecting, and investing in the fellows. It took energy and a creative spirit at DOE, within our lab, and at Activate for Cyclotron Road to get a chance to show what it could do. But the most important achievements are those of the entrepreneurs. They're tackling some of the most critical problems for the benefit of humankind and the planet. I want to congratulate them on their fortitude and spirit of adventure and wish them the speediest possible success. Thank you, and I hope you are enjoying the summit.
Thanks, Mike. We will hear from Carol Burns, who is the Deputy Director for Research and the Chief Research Officer at Lawrence Berkeley National Laboratory.
Go. Good afternoon. My name is Carol Burns, and I'm the Deputy Lab Director for Lawrence Berkeley National Laboratory. I want to add my own thanks to the Department of Energy for supporting this really incredible program, in particular the Advanced Manufacturing Office. And I also want to thank all the organizers and sponsors of this summit, including our wonderful local staff. DOE's national laboratories have the ability to accelerate innovation to impact, that is, taking something from basic science in a lab and turning it into something that can really impact people's lives. This is really critical to creating a clean energy economy. Ultimately, a path to impact is often through commercialization of innovative technologies. This is a really important role for the LEEP programs. They are an effective mechanism for accelerating science solutions for the world. The labs have expertise and capabilities to help the LEEP entrepreneurs realize their vision. For example, labs are home to user facilities, which can play an important role in the development, testing, and scaling of innovative technologies. Many of our Cyclotron Road Fellows have benefited not just from the expertise of mentors at Berkeley Lab. They've also accessed the Molecular Foundry, the Advanced Light Source, NERSC, or Capabilities Resident and other centers and facilities supported by many parts of the Department of Energy. Of the 62 companies we've supported at Cyclotron Road so far, we've had at least 20 teams with Molecular Foundry user agreements with 66 Foundry user projects, 10 bioscience teams who have accessed the capabilities of the Joint Bioenergy Institute or the Advanced Biofuels and Bioproducts Process Development Unit. Cyclotron Road companies have also accessed other laboratory facilities, including the Center for X-ray Optics, the Joint Center for Artificial Photosynthesis, as well as Cal testbed facilities for clean energy technologies and other facilities funded by the state of California, and Flex Lab for testing energy efficient building and grid technologies. Our lab scientists and our facilities and capabilities get so much in return from engagement with the Cyclotron Road entrepreneurs. It's truly a symbiotic relationship. In the end, the success of Cyclotron Road alumni companies is very inspiring. I'm grateful that these entrepreneurs have dedicated their careers to helping us realize a cleaner, brighter future I really love the secretary's term, clean energy change agents. And I really look forward to more exciting news from cohorts yet to come. So welcome.
We're good. Thank you, Carol. And thank you, Mike, for your thoughtful remarks. My name is Tom Kirchstetter. I'm the interim director for the Cyclotron Road program here at Berkeley Lab. And it is really an honor for me to be able to introduce to you 6 amazing entrepreneurs. For the summit, Cyclotron Road is showcasing entrepreneurs at different stages of their journey. Speaking of that journey, as Carol Burns just noted, the fellowship offers our entrepreneurs access to national laboratory resources, which include amazing facilities, but also amazing people. And that comes at a critical point in this journey for our fellows as they are advancing their technologies to viable market products. And as really wonderful as that opportunity is, we know that it's actually not enough because entrepreneurship, hard tech entrepreneurship, well, it's hard and it requires more than that. It also requires business acumen. It also requires keen industry insight. So to position Cyclotron Road Fellows for broad societal impact, Berkeley Lab partners with Activate. Activate brings to this program world-class entrepreneurial education, access to funders, access to industry experts, and high-touch personal mentorship for the full 2 years of the program to support our fellows as they develop as leaders, as they mature their ideas, and as they learn what it takes to build a viable and scalable business. So I'm going to introduce the first few presenters from Cyclotron Road, who are going to tell us about their technology and share with us a little bit about their journey. So the first 3 entrepreneurs are from our graduating 2020 cohort. First up is Amanda Stiles of Umaro Foods. Umaro Foods is producing and developing the most sustainable protein source on the planet. Following Amanda, you'll be hearing from Jay Schwalbe of Nitricity. Nitricity is fixing the way that we fix nitrogen. And following Jay, you'll hear from Noemi Bonessimo. Noemi is of Metaseismic, and Metaseismic is creating sustainable metamaterials to dampen impact and vibration. So please welcome to the stage Amanda Stiles. And following Amanda's presentation, you'll hear pre-recorded messages from both Jay and Noemi.
Thank you, Tom, for that great introduction. So I'm Amanda Stiles, and I'm really excited to introduce you today to Umaro Foods. So at Umaro Foods, we are developing a new alternative protein from a place you might not have expected, from the ocean. So to start off, it's not news to anyone here listening today that one of the easiest ways you can make an impact on climate change is by what you choose to eat. The higher up on the food chain that you eat, the higher the carbon emissions needed for its production. Especially, I'm talking about protein. So protein globally, livestock production creates about 15% of global emissions. Eating lower on the food chain can help diminish that. And livestock production also contributes to deforestation, water pollution, and the unethical treatment of animals. People are moving to plant-based diets, and this is reflected in the market. So in the next decade, an exponential growth is expected in alternative proteins. But to do this, we need to protect our precious resources. So as the climate warms, we need to protect both land and fresh water. Right now, where we get our protein from are these 3 places: from land, from animals, which we already know result in climate emissions, from land plants that are used in the majority for feeding these land animals, and from ocean plants, which we know we're overfishing our oceans. but ocean plants are a completely untapped white space. The ocean is the most productive, lowest cost source for producing protein. It covers more than 71% of the Earth's surface. More than 80% of the reactive nitrogen in the world is in the ocean, the building block of protein. And seaweed has a very high photosynthetic efficiency. And it's surprisingly high in protein, up to 40% by biomass. It's also a sustainable crop supported by the Nature Conservancy and the World Wildlife Fund. This in the future is where we'll cultivate our protein. So at Umaro, we're concentrating protein from seaweed. We're separating the protein from the carbohydrates that are in the seaweed, starting from, in this example, a 20% protein seaweed and resulting in a 65% protein concentrate. Our resulting protein powder is 97% digestible, full of essential amino acids, and it serves as a functional heme replacement. We're pioneers in this space, developing a protein powder at pilot scale using commercially available food equipment. And soon we're gearing up to produce it at commercial scale next. But none of that matters if it doesn't taste good. So that's why we're producing our crispy, crunchy, plant-based bacon. So this isn't a picture of real bacon. This is our Umaro plant-based bacon made with both our red seaweed protein and the special gels found in seaweed to help encapsulate the fat. Bacon is a $60 billion market. And if you'd like to try it, we're at these 3 restaurants in San Francisco, Nashville, and New York. So please stay tuned as we expand to other restaurants and into new products. So a quick shout out to the team. Our CEO, Beth Zotter, our Director of Business Development, Royal Sayowitz, and our lead scientist, Tim Arapov. And of course, a thank you to our sponsors. We couldn't have gotten started on the science side of this without the support of Cyclotron Road, the Activate Fellowship, the Good Food Institute, and RPE. So thanks so much.
Hello, I'm Jay Schwalbe, one of the co-founders and chief science officer of Nitricity. And before I start, I'd just like to thank Activate, Cyclotron Road, and the AMO for this opportunity to be involved in the Activate Fellowship. It really helped Josh, Nico, and myself as we really got our legs under us in about 2020 for this company that we spun up starting in 2018. It's been a really awesome fellowship that's given us a lot of support and really helped us get our bearings in the entrepreneurial space. So what do? So we are fixing the way that we fix nitrogen. Now, you might not have thought about fertilizer as necessarily the most trendy or exciting startup topic, but I hope I can change your mind a little bit. And so I'm going to start by showing you kind of what's wrong with how we do it today. So today, fertilizer, which is of course used to feed the world, they estimate that about only 50% of us would be here today if it weren't for artificial fertilizer, is produced in centralized Haber-Bosch facilities. And so the problem starts with the production. Haber-Bosch process takes in natural gas or coal, gasifies that to make hydrogen, and then uses that hydrogen to make ammonia. Now, of course, in the steam methane reforming process, there's a lot of CO2 is given off. And even though nitrogen fertilizer, of course, has no carbon in it necessarily, the process accounts for about 1% of global CO2 equivalent emissions. The next problem comes in the distribution. Because these facilities are such high pressure and such high temperature, they must be very large. And this leads to there only being a few hundred of them in the world. Now, when things are flowing well, this isn't necessarily a problem, at least in much of the developed world. However, given the tumult of the last few years, it's easy to see that one ship gets stuck in the Suez Canal, a freak frost in Texas at the wrong time, or on a much more serious note, international conflict can easily disrupt the flow of fertilizer and natural gas. And finally, in the application of fertilizer, because of these long supply chains, the fertilizers that are sent to the farmer ultimately are usually chosen for how well they ship, not necessarily how well they work with the soil. So today, it's largely ammonia or urea that are shipped around. And the problem with these fertilizers is that due to the microbial pathways they have to go through before the nitrogen is absorbed by plants, about 1 to 4% of the nitrogen is lost to the atmosphere as nitrous oxide. And this is no laughing matter, as nitrous oxide is 200 to 300 times more potent as a greenhouse gas than CO2. So even that small loss fraction leads to about 5 to 6% of global CO2 equivalent emissions. And this is an area that's being increasingly targeted by regulations in Europe as well as the US. And so why is the time now to start looking at solving these problems? Well, there's still going to be the necessity. Today, again, the Haber-Bosch process accounts for about half of all fixed nitrogen on the planet. So that means legumes, natural nitrogen fixation is about half of what there is out there, and the other half is humanity. We account for half of the nitrogen cycle, which is truly insane, and we need to do even more. By 2050, the UN estimates that the need for food will double due to the growing population. And today, we're already struggling to meet this demand due to tumultuous global events. So you can see global fertilizer prices have skyrocketed. This was a number that back in my PhD, when I was working on different technologies to make ammonia, you couldn't have set a number low enough to get the price right for anhydrous ammonia. And yet today, it's going up 5, 6 times. It keeps going up. And this is a pain point for farmers and really shows some of the weaknesses in our current system. Now, finally, there's the good news. The good news is that due to an increasing awareness in the private and public sector of the challenges of global warming, as well as the need to transition to a more sustainable economy, there's a great opportunity to build new industry. And part of this is the fact of the rise of sustainable and cheaper electricity. And so we look to leverage that. So how does nitricity bring it all together and solve these problems? Easy. We capture lightning in a bottle. That's being a little bit facetious, but it is essentially what we do. So we use a plasma-based process, much like lightning, to oxidize nitrogen in the atmosphere. And then we capture those products in water to make nitrate-based fertilizers. So this is an electrified process, so we lose the need for coal or natural gas. While a plasma has very intense conditions inside of it, externally it's actually fairly benign. So you don't need a high-pressure reactor like the Haber-Bosch process, so you can do this in a more distributed fashion. So this will enable fertilizer production on the co-op level or the large farm level, rather than the truly globalized versions that we see today. And finally, because we produce nitrate-based fertilizers, when used in the right way and in the right soils, these can actually have a dramatic reduction in the N2O losses. So we see kind of a way to attack the production, distribution, and application problems with fertilizer. And if that sounds exciting to you, which I hope it does, please keep a lookout through all of Nitricity's channels, so on LinkedIn, on our webpage, because we'll have a hiring push soon. So please stay tuned, and thank you very much for listening.
My name is Navi Bonesio, and I'm the founder of MetaSeismic. MetaSeismic is creating novel metamaterials to provide ultra-compact and sustainable solutions for the protection against impacts and vibration. Anything we design needs to resist impacts and vibration in buildings, equipment, or electronics. Even a small vibration can be highly amplified and cause damages and failure. For protection, we either use hardening cages or we surround objects with a large amount of isolation material, like foams. We can prevent failure most of the times, but neither of these solutions is currently enough to completely prevent damages. And they have a huge environmental impact. They are carbon intensive, wasteful, and expensive. Our infrastructure in seismic areas requires large amount of carbon-intensive reinforcement to withstand dynamic loads. Buildings need 30% more reinforcing steel and cost 40% more. Similar carbon and cost-intensive reinforcement is needed for IT equipment and batteries. And for shipping, large volumes of protective materials are currently used. 100,000 tons of such materials are landfilled every day, and foams make up for 30% of landfill's volume. MetaSeismic is creating a solution to avoid these carbon-intensive and polluting materials, while providing the highest level of protection. With this aim, MetaSeismic has a new approach. We have developed a novel class of metamaterials that protect not by volume, like current solution, but rather through the small mechanism these materials have inside. Our artificial intelligence algorithm can design ultra-compact, low-carbon, and high-performance metamaterials for solutions across all industries. Our algorithm uses the vibration as an input to create a metamaterial that is exactly what is needed to fully protect an object from damage and failure. The algorithm uses a wide database of material properties, manufacturing methods, and internal mechanisms to make the protective metamaterial layer thinner than anything else on the market. This video shows how a thin layer of metaseismic filters out the vibration from the glass on the left. Imagine how the same metamaterial can protect an electronic device during shipping. An example of metaseismic application is packaging. While protective foams require a large volume to absorb shocks, a better protection can be provided by a much thinner layer of dynamic metamaterial. These compressive tests show that the thinner layer of metaseismic can replicate the stress-strain cycle behavior of a large foam pad within the typical stress range for cushioning applications. By modifying the internal architecture, the algorithm improves the protective performance of traditional foam by reducing cycling degradation 10 times, doubling the energy dissipation, and reducing permanent deformation resulting from shocks by 15 times. And the life cycle assessment of metaseismic shows a 10 times reduction in greenhouse gas emissions compared with the foam used to ship electronics. The analysis considers the overseas shipment of server racks and assumes, based on experimental data, that metaseismic can be reused a minimum of 10 times and can save 10% of cargo space in ships due to its reduced volume. The assessment also shows lower impacts on human health, ecosystems, and resources when compared with the state-of-art foams. Our platform has applications across high-impact markets, from the packaging industry to building, aerospace, and automotive sectors. During the program, the support from Cyclotron Road and Activate was fundamental, not only to validate the technology, but also to start the pilots with tier 1 electronic companies to commercialize the technology. And the next pilots will be in the aerospace and automotive industries. Thank you.
Thank you, Amanda, Jay, and Noemi. A shout out to Jay. I think that was the first joke I heard of this summit. Nitrous oxide emissions are not a laughing matter. He'll be here all week. Our next two presenters are from our 2021 cohort, which means they're just now beginning to enter into the second year of their fellowship. We'll hear first from Pete Christensen of Flow Materials. Flow Materials is developing infinitely recyclable polymers to enable circular design. And following Pete, we're going to hear from Aaron Hall of Entropic Materials, making truly compostable plastics for a circular bioeconomy. So let's welcome Pete to the stage.
Great, thanks Tom, and thanks for the local team here for putting this event together. This has been fantastic so far. I'm Pete Christensen, CEO and co-founder of Flow Materials. And at Flow Materials, we believe that design for the circular economy, design for an end of a product's life, is the future of all products. However, the available portfolio of infinitely recyclable materials is significantly limiting to product design. Now, this is particularly true of plastics. Now, plastics are great materials. They're inexpensive, they're lightweight, and they can be formulated to exhibit a very broad range of functional, mechanical, and aesthetic properties. However, more than a quarter of all plastics and polymers that we produce are currently not recyclable. I'm referring to a class of materials called thermosets. Thermosets can be found in things like composites, rubbers, foams. Tires are made of thermosets. And owing to their three-dimensional connectivity of the chemical building blocks, these materials cannot be melted and therefore are very difficult to recycle. At Flow Materials, we're directly solving this problem of network polymer recyclability by introducing a new way to both manufacture and recycle these types of materials. Our core intellectual property is shown on the left here, where we've invented a new bond that can be disassembled at the end of life, allowing us to recover the building blocks to make these materials again. And now when applied to the synthesis of materials, we can use this reversible bond to make these network polymers. These network polymers can, of course, be formulated by adding plasticizers, dyes, flame retardants, all the things that we would need to add to make functional products. And the secret sauce here, what's really magical about this system, is at the end of life, these PDKs can be disassembled to give us back the chemical building blocks to remanufacture these materials with lossless quality. In addition, we can remove all of these additives that we put into the material at the end of life. PDKs are a platform technology. So we have the ability to formulate these materials to exhibit a very, very wide range of both mechanical and aesthetic properties. They can be synthesized from a wide range of commonly and inexpensively available feedstocks. We also see the PDK chemistry as a way to unlock chemical circularity in a wide range of currently available polymer systems. And so if you or anyone you know work with either of these feedstocks or any of these polymer outputs, we would love to speak with you. Through Energy iCore, we tried to identify where to start. And so we have this platform technology. What should we make first to demonstrate that we can both manufacture with these materials and also demonstrate that we can recycle? And so we wanted a product that generated a lot of waste quickly, something that had high material costs and had high retail margins and also low material requirements. We wanted to, as we're scaling this material out of the lab, work directly with manufacturers and put a product into customers' hands very quickly. And also in the style of Doc Brown from Back to the Future, if you're going to build a time machine, do it with style. That resonates very strongly with me and my team. And so combining all of these selection criteria, we settled on making eyewear as our first product. And I'm very happy to announce and introduce to you the first pair of Flow Materials eyewear in my hands and now on my face. Very exciting. So while many of you probably have multiple pairs of eyewear, spectacles and sunglasses, what you may not know is that the manufacture of these products generates a huge amount of waste. And so this slide shows a sheet of Flow Materials PDK going through, dropping directly into one of our manufacturing partners' manufacturing process. And so you start with a sheet and you subtractively manufacture away about 90% of the material that goes into this product. And so the output from this machining process is shown on the right, where a very small quantity of material actually ends up in the final product. All of these bits in the middle and this material on the outside of the frame is discarded as waste. In aggregate, this results in about 25 million kilograms of material for these products alone thrown away every year, which is about $750 million in materials inefficiency. So we think we can absorb quite a bit of this by bringing our materials directly to this market. So as we scale into the eyewear industry and beyond, our vision as a company is to be both the beginning and end of the materials life. And so we identified through iCore that it's not enough to bring new material solutions to market. You also have to help people close the loop in these materials life cycles. And so we want to offer a very broad portfolio of these infinitely recyclable materials while also providing recycling as a service. We're a small but growing team. I'm very excited to be working with my partner in crime, Kezi Chang. Teamwork makes the dream work, and I can't think of a better person to be working on tough problems with. I'd also like to thank the Department of Energy Advanced Manufacturing Office for sponsoring us in Cyclotron Road. And thank you very much for being here and for listening. Happy to connect after the event. Thanks so much.
Hello, everyone. I'm Aaron Hall, founder and CEO of Entropic Materials. And today I'm going to tell you about our work commercializing truly compostable plastic for the circular bioeconomy. Now, plastics are everywhere, thanks to their amazing properties, their easy manufacturing, and their low cost. Unfortunately, this ubiquity is creating an environmental disaster, polluting our land, water, and increasingly our bodies and those of our animal friends, thanks to microplastics. And that's because they're not trivial to dispose of. I'm sure everyone here has had the experience of standing in front of a set of bins, wondering, where in the world do I put this? And just because it has some chasing arrows is no guarantee that a product can actually and will be recycled. And who knows what to make of all the eco-conscious signaling that's out there. There's a lot of greenwashing. We need something that's both easier and better. And I believe that true compostability is key to achieving that future sustainable plastics economy. And the market agrees. We're seeing an increasing number of compostable plastic products hit the shelves, and the market is already in the billions of dollars and is growing fast. Through participation in the NSF I-Corps, I interviewed over 100 stakeholders in this space, and through those conversations, learned that these products that are hitting the shelves don't always deliver on their breakdown promise. The reality is that the composters are velocity-driven businesses, and their 40 to 60-day turnover times are just a lot faster than the 80 to 180 or even more days needed for breakdown of these products. Faster degradation is key. Now, the reason the current degradation is slow is because in nature, plastics degrade from the outside in. Microbes in the soil use enzymes, represented here by these green circles, to chop randomly at the surface, leading to inefficient breakdown and the formation of microplastics. Our approach is to eliminate that middleman and embed the enzymes themselves directly inside the plastics. These materials can then uniformly degrade from the inside out. Further, this happens under a unique mechanism where each polymer chain is degraded monomer by monomer from the end, yielding only small molecules, no microplastics. And this isn't just theory. We've shown that the approach works. On the left, we have enzyme-embedded fibers that were extruded at industrially relevant temperatures that rapidly and completely degrade in simple warm water baths. Further, we can actually recapture and repolymerize the small molecules that this produces, leading to an awesome circular economy approach. And on the right, we show enzyme-embedded polymer films degrading in simulated compost conditions. We get immense degradation in days, not months or years. We have a wonderful set of go-to-market potential that we are actively exploring right now. Our approach provides value across the entire value chain, expanding the design space for products and eliminating concerns around degradability. And this is all enabled by our nanoprotectant platform, which lets us stabilize enzymes outside of cells within chemical solvents and materials. I like to think of them as PPE for proteins. They keep them safe while they do the hard work. We're living through a biotech revolution, which is playing a key role in our move away from petroleum. Enzymes are the workhorses of this shift, and our stabilization platform unlocks and expands that market. Last month, I hired my first employee, Jolene Matson. As head of process engineering, she's leading our move from bench up to the kilo scale, and I'm actively hiring for chemists, engineers, and scientists. I also have wonderful advisory support from Ting Xu, my academic advisor where the work started, as well as numerous industry veterans. I'd like to thank DOE AMO for sponsoring my participation here in Cyclotron Road and the Activate community for all the mentoring and support. The NSF for that support in the I-Corps programs, UC Berkeley and all the others who've been a wonderful bolster to our product and our technology. My contact is here, Aaron Hall at entropicmaterials.com, and I'd love to chat with you further. Thank you all for the space and time.
Thank you, Pete, and thank you, Aaron. So we have one more presenter, one more speaker representing Cyclotron Road, and he is an alumni of Cyclotron Road and Activate from our 2016 cohort. He's the CEO and co-founder of Cuberg. Cuberg is powering the future of mobility. So please give a warm welcome for Richard Wang.
Good afternoon. My name is Richard Wang, and I am the founder and CEO at Cuberg, where we are commercializing next-generation lithium metal battery technology to power the future of electric mobility and the most demanding applications out there, from electric aviation to long-haul trucking to maritime transportation. But this is a story not only about Cuberg, but really about how Cuberg is a true example of successful government policy and public-private partnerships at work through Cyclotron Road and through the Department of Energy. My journey in clean energy started actually back in 2009 when I was still an undergrad at Caltech in Southern California. And we participated in the Department of Energy's solar decathlon competition, where 20 university teams fought it out to make the most advanced net zero solar powered houses. And this really inspired me to launch a career in clean energy. I then ended up at Stanford University, and this comic you see, which is actually something we put together for our Cyclotron Road application from 2015, actually shows a little of our journey, starting at Stanford, where my PhD work was really funded by the Vehicle Technologies Office to a large extent, and where I spent lots of my time at the national labs, including SLAC, Argonne, Oak Ridge, and Lawrence Berkeley Lab. And that journey ultimately led us to Cyclotron Road, which has been foundational to our success as a company. If you zoom in on the bottom right panel of this cartoon, you'll see, I think, the most interesting panel on this slide, which really describes our company journey very succinctly, which is that Cyclotron Road has been instrumental in the success of our company and in guiding us along a journey that is incredibly difficult and perilous for any startup. Any startup is challenging to run. Battery startups are particularly incredibly difficult to run successfully. And with the support of the Department of Energy throughout our lifetime as a company, we've made it to the top of that mountain, or at least the first mountain that we're climbing, through to our successful acquisition and exit early last year. We're now well on our way to developing most of the things you see at the top of that mountain, including electric planes, drones powered by our batteries, and essentially flying cars. The phone flying around in there, maybe we're still a little further away from that one, but well on our way towards achieving our original vision with Kubrick. And so with our acquisition, we are now part of a mother company called Northvolt. This is a leading European manufacturer of the world's greenest and most advanced battery technology on the planet. And Northvolt is a company, while a startup, that's incredibly well resourced and funded. They've been around about 6 years. They have 3,000 employees. And the combination truly of Northvolt with their resources and manufacturing scale and supply chain sophistication, combined with the advanced technology and nimbleness of Kubrick as a technology startup, it is truly unique in the battery industry. And Northvolt is not only building out gigafactories, but they're doing it in the right way, with the most sustainable manufacturing practices powered by clean energy and highly sophisticated and efficient supply chains, really focused on localized supply chains and domestic sources of critical materials. And with Northvolt, we're really building out not only a technology, but an entire battery industry in Europe and in the United States, focused on localizing critical materials from mining through to materials processing to cell and module and systems manufacturing. And I'm excited to announce today that we are well on our way towards developing not only a battery cell, but the world's most advanced battery module and system built on the most advanced aviation manufacturing line in the world, right here in the United States. This will directly lead to the creation of many hundreds of jobs, billions of dollars in economic impact in the US, and really cement the US's early lead in driving forward the next generation of aviation. The battery is as critical to the success of the electric aviation era as the jet engine was in enabling the success of the jet airline era. And together with the continued support of the Department of Energy and through visionary acts like the Battery Infrastructure Law that was recently passed, we believe we can work together to truly make this future vision of battery-powered flight a reality for everyone. Thank you for your support.
Thank you, Richard, and thank you to all the speakers representing Cyclotron Road at the summit. I am really inspired by what you do. Congratulations on all your achievements so far, and we're looking forward to what you do moving forward. This ends Cyclotron Road's presentation for the summit, but please do stick around, of course, for the Inclusive Innovation Panel, which will be moderated by DOE's own Shalonda Baker. So I want to thank all of you for being in the audience. I want to thank all of you for tuning in out there. And I'm glad to turn the mic back over to John Carlisle in Chicago.
Fantastic, Tom. Congrats to the whole Cyclotron Road team, Tom, Melanie, everybody. Wonderful, wonderful segment.